Hello viewers and my dear students. Welcome to Problems on One-Dimensional Truss Analysis. Here I'll be showing you a demo on problem 2, that is session 1, on typical railroad bridge problem analysis using Ansys Release 14 of Mechanical APDL. You see here the problem is this. The problem is this. That means a small railroad bridge is constructed of steel members, all of which have a cross-sectional area of 3250 millimeters square. A train stops on the bridge and the loads applied to the truss, this is the truss structure, on one side of the bridge are as shown. Estimate how much the point R, this is the point R, estimate how much the point R moves horizontally because of this loading. Determines also the following, assuming E to be steel, that is 200 GPa, nodal displacement, reaction forces, forces in each member, stresses in each member and all that. This is a typical problem what you find in most of the universities, particularly with respect to FEA lab. This you are doing using Ansys Mechanical APDL. See here, as you see here, this is the model and the load that is coming upon this is 280 kilonewtons, 210 kilonewtons, heavy loads, 280 kilonewtons, 360 kilonewtons and all that, and it is fixed here, all degrees of freedom arrested. Here, as you know here, it is roller supported. That means movement in X direction is allowed. That means because of the loading, this moves horizontally, and in fact that is the thing they have asked. Estimate how much the R moves horizontally because of the present loading condition. How much the R moves horizontally also you have to find out. Okay, and also nodal displacements at so many nodes, no, 1 2 3, so many nodes are there, and you have to find out how the nodal displacement and reaction forces also. Reaction forces, because of this loading, no, there are two supports here and here. What are the reaction supports you get, that you have to find out. Forces in each member. Here there are actually, if you see here, 1 2 3 4 5 6 7 8 9 10 11 members are there. That means because of this loading, some of them may be subjected to tensile stresses, some of them may be subjected to compressive stresses. When you list out, we will do that. When you list out, you will know the positive ones are the tensile stresses and the negative ones are the compressive stresses. Okay, forces in each member, stresses in each member, everything you can do. First, we'll start with this. Okay, now using Ansys APDL. Okay. See here, I have already done. I have changed job name. Change job name you do. I have given Gurdat problem 2 on truss, and also change title also I have given. Okay, change title also I have given. Okay, this if you see truss analysis railroad bridge problem. This is typically known as railroad bridge problem in every university. As I told you, it's a common question asked. Okay, now what we do is you do in the same way. First, I'll just check log file. You see, nothing has been created. It's a fresh log file I've created. As you know, we'll solve this in session 2, copying this and pasting in the Ansys command prompt and solving the problem by changing the loads and all that. We'll do it. This you should know it. And I'm telling you, there are two methods of doing. What I'm doing right now is graphic user interface method, GUI method. And getting a log file and solving using log file is, you can call it as a macro file operations or log file operation. That is another method of solving. Okay, this I'll close now. Okay, now I am doing by guy. See, that is graphic user interface method, and as you know, as and when I do, automatically this log file is created. Okay, don't worry about that right now. We'll try to complete this problem using graphic user interface. Preferences you go. Structural you go. Okay. Okay. Then preprocessor, element type, add, edit, delete, add you do, and as usual, this is one dimensional problem. Okay. You take link 180 only. Okay. Link 180 only and just say close. Okay. Now as you say, see here, this real constant, no? You go here, first you see the real constant. As you see here, this rail bridge is constructed of all steel members, all 11 steel members only. Cross-sectional area of 3250 millimeters square. Now what we'll do is, we'll not change this. We'll have millimeter only, so that this entire model, this they are given in meters, no, we'll have it in millimeter only. Okay, and this kilonewtons, I'll take it in 360 into E3, that is 360 E3 newtons, 280 E3 newtons, that is I'll multiply by 10 to the power of 3, so that it will be newtons only. And this E, very careful, 200 gigapascals, I'll give it as 200 into, that is 2E5 I'll make, that is 200 into 10 to the power of 3, okay, 10 to the 200 into 10 to the power of 9 Newton per meter square. But when you convert into Newton per millimeter square, it is E is equal to 200 into 10 to the power of 3 Newton per millimeter square, or 2E5 you take. That is why we will have the consistency in units. All mm and newtons will have it. Okay. Okay. This model you should see. You see here 000 here. This is 3600. This is 3600 plus 3600, 7200. And this is 7200 plus 3600, almost 10,800. In that way, we will have to create the key points in that way. This point, as you know, it is 3118, okay, millimeter, because 3.118, no, 3118 millimeter, and half it is, that means it is 1800, 3108, okay. In that way, we'll create the key points and all that. And carefully, I keep showing you this, we'll do it carefully, okay. Now, as you see here, element type, add, edit, delete, okay, and see here, this link 180 I have fixed. Then real constant you go, and real constant, add, edit, delete, add, and as you know, for this, the real constant is 3250 millimeter square. Okay, this you say, this you please check. This is for the entire thing, it is 3250 only. Okay, 3250 mm only. That means real constant is only one, and even material is also only one. Okay, that is why this you have to know. Okay. Okay. Now, as you know here, material properties I'll go, material models I'll go, structural, linear, elastic, isotropic you go. Here, this they are given 200, E3 I'll take. 200 or 2E5. Okay. This is what they are given here. This is exit. Okay. Because they are given, assume 200 GPa. That is 2E5 or 200 E3. That is what I have done this. Okay. Material models. I have created this. If you want, you can check it here. 2E5 I have entered correctly. Okay. Then once you know it is correct, now I'll start creating the model. Modeling, be careful here. Create key points in active coordinate system. See carefully. 1, I'll take 0, 0, 0. Okay, I think you agree. First 1 is that. Then 2 you take. 2 is 3600, 0, 0. 3 is 3600 plus 3600, 7200, 0, 0. Okay. Then 4 is 10,800, 0, 0. Okay. Apply. Then 5 is 3,000, that is 1,800 and 3,118. 5, 1,800 and 3,118. Okay, that is this. Apply. Then 6 you take. This is 5,400, 3,118. That's you say apply. 7 you say. Then this is 9,000. That is 5,400 plus another 3,600. It is 9,000. 9,000. I say okay. Okay, 1, 2, 3, 4, 5, 6, 7 key points I got, all based on this only. That is, this is 3600, this is 7200, this is 7200 plus another 3600, 10,800. And this point is half 1800, 3118. Okay, then this point, no, this is 3600 plus another 1800, that is, this point is 5400 and 3118. This point, no, this is already 5400 here, 5400 plus 3600, this is 9000 and 3118. Okay, in that way I have got this. Okay, in that way I have got this. Now what I'll do is create lines, straight lines. I'll join this to this to this is the same way you join, because I want that is totally I want 11 elements to be created. Okay, see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 elements have been created. Okay, this you just say okay. Okay, now as you see, now you see here, next we go for meshing, mesh attributes, no, I'll take default attributes only, because there is only one element type, that is link 180 only. Material, there are no different materials, there are no real constant, different real constants. Only one material which is steel, and only one real constant, that is 3250. That is why I'll just say okay. Meshing, mesh attributes, default attributes only you take. Okay, that means this is the thing. Then you go for size controls, manual size, lines, all lines you take. And number of divisions 1 you do. Number of divisions 1 if you do, there are 11 lines. Okay, then I have divided into only one division. As a result, 11 elements only you get. Then what you do is mesh you do, okay, lines you do, okay, pick all you do. Once you do this, you are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements. If you want to check, it is list, elements, nodes, attributes, real constant you do is here 1, 2, 3 up to 11. All real constants are same, 3250, 3250, 3250. Can you observe? There are 11 elements which have been created. Okay, 11 elements. All are of cross section 3250 only. Now, this is up till here, this is called pre-processing. Okay, now we'll come to the solution phase. Okay, in the solution phase, what we do is we assign loads. Okay, we assign loads and boundary conditions and all that. Okay, now you see whatever we have fed right now, you can check in this way. List, key points, coordinates only if you see, one is 0, 0, 0, correct it is. Okay, then I'll just see, I'll make it this way. Okay, plot controls, numbering, node numbers on I'll do, and element numbers also, element numbers also if you do, you get like this. These are all element numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are all element numbers, and node numbers are this 1, 2, 3, 4, 5, 6, 7 are node numbers. In that way, you have everything. Okay, now if you see list, key points, coordinates only, you can clearly see 1 is 0, 0, 0, 2 is 3600, 0, 0, and this is 3 is 7200, 0, 0, 4 is 10,800, 0, 0, then 5 is 1800, 3100, and then next is 6 is 5100, say 3118, 8, that is next is 9000, 3118. In that way, everything you get it here. Okay, now we have come to the end of session 1. We'll continue this problem in session 2. Did you follow? Please follow. If you have given this 1, 2, 3, 4, 5, 6, 7, and you can always see in the list key points, all coordinates you verify. This is 1 is how much, 2 is how much, 5 is how much, 6 is how much, 7 is how much. Everything has been given here. Okay. Thank you.